All right, thank you for joining us. My name is Diana Honish-Haig, and I get to serve as the Director of Retention for our online master's degree programs at the University of San Diego. Here with me this evening for part 2 of our Agentic AI workshop series is Dr. Desai. He is the passionate founder and CEO of Ready Tensor Incorporated. He's a seasoned AI industry leader, also admired for his strategic vision and hands-on approach and an unwavering commitment to making AI accessible to everyone. His previous roles include Vice President of Product for DaVinci AI at Verint Systems, where he integrated AI across the product line, and Vice President of Analytics at Kiran Analytics, where he spent 14 years spearheading innovative analytics solutions. So educated at Texas Tech University with a Ph.D. and a master's degree in industrial engineering, and Pune University with a bachelor's degree in product engineering, Abus excels in translating complex AI capabilities into practical industry-wide solutions. So please join me in welcoming him.
Thank you, Diana. Thanks for giving me this opportunity to present to your group today. Diana, there is going to be one member from our team, although I will do most of the talking, but in case I have any questions, I'll ask her to support. Just so you know, there's one person from our team on the call today. So yeah, thank you again for this second session. This is part 2 of 3-part workshop, and I'm quite excited to take you through today's session. So I will. Diana's given the introduction, so I won't spend too much time. The only thing I will add to what Diana mentioned is that I'm currently the CEO and I'm the founder of a company, Ready Tensor, and I will bring up some use case, some case study from what we are actually doing with Agentic AI. And I thought, that might be a good case study to go through as we do the session today. Okay. All right, so what we'll cover today, I will do an introduction around the topic of Agentic AI. In part 1, we went through some workflows related to large language models. I will connect that with what we will do today. Today is more like a progression, one step up from what we covered last time. So we'll do an introduction to AI agents, and then go into multi-agent systems, talk about how you set up multi-agent architectures, collaboration, handoffs, delegations, and so on. Next, I want to get into a case study. When I was originally planning this session, I want to be transparent about the intent. So we wanted to actually get you a hands-on experience into implementing agentic systems. And that's what we did in the first session, although that was more based on simpler workflows. And as we tried to plan for this 1-hour session, we just realized we're just not going to be able to do justice in 1 hour and help you implement AI agents implemented. It's just too much to cram into 1 hour. So we're going to do these things differently. I will show you some hands-on working examples of agentic systems. And I want to just make it a little bit more interactive with your group, so you can start thinking about design and implementations of such systems. So yeah, that will be the case study we'll use. And we get into n8n, a tool that we're going to use in the demo today, in the examples. And also a very intuitive, easy to use tool platform for building agentic systems. It's drag and drop. So we'll take a look at it. And then I also want to finally end on some realities, Agentic AI realities in terms of challenges of implementing such systems. And it's really going to get into be a good transition for the next session we'll have next month, which is around the evaluations, safety, security, robustness, reliability of agentic systems. So what we call the production readiness of these applications. So that's really next time, but I want to just get into that when we discuss it today. So let's get started. Introduction to AI agents. Okay, I covered this a little bit last time as well. So what is agentic AI? It's any autonomous system, a system which can reason, plan, and act independently. And the core ideas there are the autonomy angle. These systems have a little bit of autonomy given to them in terms of how they are able to conduct the task, achieve the task. And then the second aspect that I would say is crucial for agentic systems is the pursuit of goals, right? So you give them, these agentic systems, some task to achieve, and then there is that autonomy. Again, within reason, you don't let them have free rein. There have to be some guardrails, boundaries on the systems. But within certain reasonable boundaries, you give them the autonomy to achieve those tasks, those goals. So the behavior of pursuing goals and then choosing the path to get to that goal probably are the quintessential properties of agentic systems, truly agentic AI systems. Okay, so we'll take a look at some examples today as we go through it, but just understand that's the core idea of agentic AI. Okay. Last time I did, I think this slide as well. I wanted to just present the levels of agentic systems, and the box on the left-hand side is what really we covered in session 1. These are LLM workflows, meaning there are large language models used in these workflows, but there is no autonomy aspect to them. So there's use of generative AI to achieve certain tasks. But in a true sense, we are not really giving them the power, the flexibility to achieve the task in different ways. And many in the industry will claim that LLM workflows are not really agentic AI systems because there is no true agent. The word agent, as you know, agency is when you have some freedom, some flexibility to do activities. And if there is no agency, you're basically choreographing everything in the application, then how is it agentic AI? So nonetheless, if you have these LLMs doing certain tasks, the behavior of these systems to an external person it's very hard to discern if it's really agentic or not, behind the scenes. Now, we've actually implemented a lot of systems that other people have thought use multiple agents, and we didn't. It was purely LLM-driven workflows, and so really, it's hard to make that to distinguish these from the user experience perspective. And so with that in mind, I just put it in a dotted box there. Okay. So agentic AI, truly agentic AI, we're going to look at single agent systems today and multi-agent systems. In terms of more yeah, okay. We'll look at some of this. I will give you opportunities to ask questions. I'll pause at certain points, and at the end as well, we'll have time for questions. Okay. All right. So let's just take a look at what a single agent is able to do. Okay. All right. What is an agent truly? I would define it as a pod, as a cell, which has as a brain an LLM unit in it, right? So a large language model, whether it's from one of these frontier labs like OpenAI, Anthropic, or Google's Gemini models, or it could be an open weight model, right? So some large language model is at the center of it. And then in addition to that, you give that unit certain capabilities. So tools are basically some ways of achieving certain tasks. And we'll look at some examples of that in one of the demos. I mentioned the lower three parts are really cognitive elements: planning, reasoning, autonomy. And I'll talk about that. I want to actually really be clear about what that even means. So yeah, LLM, as I mentioned, is there. Let's talk a little bit about memory. The term memory is, I mean, I brought this up before, is widely used, but is quite misleading. There's actually quite a few terms that annoy me in the AI ML space, and memory is one of them. I mean, I don't hold the grudge against use of that term, but it gives off the wrong vibe, wrong idea. So in agentic AI systems, especially with large language models, there is no true memory given to them. Okay, there is no inherent like how we think of memory, right? We experience certain things and we remember them later on. With large language models, there is no true concept of memory there. What we mean by memory is just truly, I mean, this is going to be like sound like really, you're going to be not believing me, but a prompt. Whenever you're chatting with a large language model, like in a chat GPT console, you know how you interact with it and it responds to you, and then you might be having a chat and it feels like it has memory of it. And the way it's really implemented is every time you're asking a new question, the entire history of that conversation is being fed as one giant prompt. As if, you know, user said this, you said this, user said this, you said this, and this is the latest user question, now answer. That's all. That's what we call memory. Okay. Now, I've simplified it because there's different elements of what might constitute memory. And these days, the last session, actually, we looked at RAG systems, retrieval augmented generation. You can say, well, that's a little bit more intelligent implementation of memory. Again, you're just pulling information, and there's some additional details. So what has started these days, you know, a trend is not to call it memory, but to call it context engineering. Really, what we have is the combination of prompt engineering, which you may have heard a lot, and memory is now context engineering. So context engineering is basically every large language model has a limited context, how many words, how many tokens you can give it, how much history. And so it has to fit within that. And context engineering is how do you intelligently pack all of that information to get the most intelligent quality answers. Okay. That, you know, I could do a whole other set of lessons just around context engineering. So anyway, I talked a little bit longer than I wanted, but it's important. Memory is just context. All right, the bottom three: planning, reasoning, autonomy. I want to be clear here. All of these terms are labels that we humans have put on some patterns we see in the outputs of large language models. None of these large language models have any intelligence in them. Well, in a true sense of the word intelligence, right? So they cannot think, they cannot reason. There is no causality. There is no, true kind of thinking and planning that humans do. What we call planning, reasoning here, or autonomy, is essentially making the large language model respond in a way that looks like how a human would plan, reason. So when you give it certain tasks, you might prompt it to say, give me the steps, okay? Give me the pros and cons of this, or tell me why you're doing that. And then it writes it out, and we look at it and say, yeah, that looks like how we would reason, okay? So, but however, these LLMs don't actually do that. They're just next token prediction engines, okay? There is no true planning happening. It's just, it imitates, simulates how we would plan. So it's important to know that none of these language models have any kind of intelligence, true reasoning power in them. It's the behavior of outputs, okay? So, all right. All of these are things we design in the system, and together we say that's an agent. Okay, now some cases you might say, none of this, you don't have to have all of these elements to make an agent, and that becomes a subjective term, and I'm not going to argue against that. But these are the various properties you might see in an agent when you're talking about agentic systems. Okay. I'm going to give you a chance to ask questions. I want to make sure I'm not going to run out of time, and I'll take a pause. Okay. So when you go from one agent to multiple agents, what we are really talking about is putting these agents together in some structure like a team and making them achieve some task, right? So now this this is where, the chart I'm showing here is typically what you would see in other literature around agentic design too. I want to be clear, yeah, these patterns do exist. What you're seeing here, I'll talk about them in a minute. But in reality, every practical real-world system, you're not really saying, okay, this is exactly this pattern. This is an assembly line pattern. This is a reflection pattern. What you're really doing is putting different types of patterns together in a more complex graph. Okay, and to be clear, to me, this composition of AI agents is really not much different than thinking about how we would put human teams together, right? If you're achieving certain tasks, you're putting a staff together, a group together to achieve certain activities. We think about what is the overall goal of the team, what roles we want people to play, what skills will each of the team members have, what are the clear responsibilities and handoffs, who does what. You want to make sure like you're not stepping on each other's toes. It's a clear delineation of responsibilities, and that work is achieved in the right manner, right? So it's the same thing with agentic AI systems. Think of it like no different than human kind of capabilities. Now, having said that, it's more a notion I'm bringing together. No AI agent you're going to build today. This will change maybe 20, 30 years in the future. No AI agent today is going to have anywhere close to the capabilities of a human in terms of cognition. So when we talk about AI agents, they are more like narrower definitions. They're like very small skill set you're going to assign, and you're going to say this is an agent. So we'll see when we get into the case study. All right. So yeah, let's look at this at a high level. You have assembly line. Basically, you put agents together in kind of a sequential manner, and the first agent does something, it takes an input, produces an output, which the output goes to the next agent, again does something, and so on, right? It's a sequential task, and at the end you get the output that you were looking for. So it happens, but you're usually not going to have a really long chain of agents. You might have at most 3 agents like back to back, because these agentic systems, you might have heard, have the risk of hallucinations, making things up. And the longer the chain is, the higher the risk that something breaks pretty badly somewhere along the line, and the output at the end is garbage. So you have that. Then you have reflection pattern. It's actually quite common to have a reflection kind of pattern within an agentic system, where you have like a creator and a reviewer, in a way, like a doer and a reviewer. One agent does something and passes off their work for review to the other agent. The other agent critiques it, gives feedback, it goes back to the first agent, and you might have that repeat kind of loop occurring there. Supervision pattern would be like a manager at the top, an agent dividing up some work into smaller tasks and then passing them off to different agents to do that work. Okay. And then you have these other more complex patterns you can see. Hierarchy would be like more than 2 levels of such work being done, managers and team leads, and then worker nodes, if you think of it that way. So you have that. Competition is like when you give multiple agents the same task to do, and you just pick the best one. So really, we do this all the time. I mean, we do this manually all the time. I assume you tried it. Like you sometimes go to ChatGPT and try something, and you might go to another chatbot like Anthropic Claude, and you give it the same thing. You ask and you compare the answers, and you pick the best one, right? We do that all the time, actually, things like that. So it's a competition pattern. And then network is just very complex patterns of agents, like giving off tasks, and they're going around in a complex pattern. So these are possible patterns, but really real world systems are like a composition of all of these put together, depending on the use case. Okay. All right. So I want to get into agentic AI authoring system. So I will pause for maybe 2 questions. I do want to get into. I want to make sure you do have time for questions at the end, but let's take a couple of questions here. Someone was raising a hand. Come on, speak up. Okay, chat. Let me see. Okay, maybe not. Can you clarify the terminology one more time? How do we know if there is a true agent? Yeah. Yeah. So I would say, yeah, as I said, the agent, well, a very hard, like, this is, you're always going to have a little bit of like a spectrum. Okay. I want to give you like one case where which you say, okay, undeniably, that's got to be an agent. So you have an LLM, you give it some task, and the agent has multiple tools available to it. Okay, so let me just make this real. Okay, you're asking for some information, and you want to retrieve some information. Let's say the agent has different sources from where it can pull information. One is it can do a web search. Okay, it can actually just go and search. The other might be that it has an internal database of knowledge documents from a company. Okay, and so it can look there. And the third might be it can look up maybe like archive, right? Academic, like scholarly papers, and it has some subscription, access to look up papers. So maybe you give it some task where you say, I'm looking for information on this. And the agent is given the autonomy to say, let me make a call. I think I might be able to find this information within the internal company knowledge documents. And then it goes and retrieves using a RAG system some information, which might be a tool, right? That RAG retrieval might be a tool. And it gets that information. Then it actually looks at that information and makes the call that I don't think I got the right information here. I'm going to now go and search the web to see if I can find more information. And then it goes and starts looking for, uses another tool. We're going to use one of those tools today, a web search one in a demo. And yeah, it looks for that information and so on, right? So here you can see it has autonomy. It has different tools. It's deciding what to do. It can look at the output and say, okay, this doesn't really answer. And so it's choosing its own path. And it's choosing at the end to say, okay, I think I have enough information. I'm going to pass this back to the user that asked for this. So all of that, by the way, you can achieve today with very basic, tools. I say basic, but this is possible within a couple of hours of work. So yeah, that would be a true agent, right? You've given it quite a lot of capability to look up information. Okay, all right, I'm going to move on. So agentic authoring assistant. I'm going to first, before I get into this case study, I want to show you an example of an agentic system on the Ready Tensor platform. This is actually in use. I'm going to show how what users can do. So the Ready Tensor platform is where this is open, free to join and share your work. So on the platform, what we have is students, AI/ML community from all around the world can share their AI projects, data science projects, and look up other projects from the community, right? So I just went there, and this is what is showing right now. But here's an example. Someone has published their project around foundational agentic AI system, and they've shared some information. I won't walk through this, but they can share their code and so on. So yeah, this is an example. Now, what we find is a lot of the community members they struggle to write. They're not the best writers, and so the project might be outstanding, but they sometimes don't do a really good job of sharing the work and highlighting what they've achieved. And so what we did is to help them to assess their work. Imagine like an auto grading system and feedback system. We built an assessment engine. Okay. So by the way, I forgot to turn off the lights and turn on the lights. So let me do that real quick. I'll be back in 5 seconds. Okay. So let's assume that I am one of the community, the platform members, And I've done a project, doesn't matter what it is, just as you know, assume this is your data science AI ML project. You want to share this on this through this platform with the community. So yeah, and it would let's just say it looks like this. Let me actually refresh the page. And yeah, so we've done some work and a write-up and so on. So it doesn't matter. We have this now. Let's say as a platform member, I want to get a gauge on did I do a good job of writing this? Okay. So we have this automated assessment capability. I've already run this, but I'm going to rerun it. So yeah, assess this publication. We call them publications. It's basically what your project shared as a submission to the community. So let's just run this. It's going to take maybe a minute to run, but let me explain what is happening while that is going on. So this agentic system is going through the write-up, and it is we have a technical rubric, like a set of criteria, technical criteria, like the kind you would see when you publish a paper in an academic paper, academic journal or a conference, peer-reviewed, and we assess the work. And there's like a set of almost 100 different criteria. Not all publications have all those criteria get applied to them. It depends on the work you're doing. So depending on the type of project, you get certain criteria applied, and then you get a score around it. And I think it just finished. Here, this publication, the automated system did actually it decided that this looks like it falls under two categories. It's a tutorial, and then it's an academic solution showcase, meaning like a student project in a way. And so let's take a look at that. This project was indeed a student project, and it's basically data criteria and assessment saying this is what you've done well on this your write-up, but here are let me see, yeah, all the way down. It needs improvement in these areas, right? So it's missing a few things. Let's just say limitation discussion, right? The publication does not discuss any limitations, trade-offs, potential issues related to your project work. So, where are certain constraints in your work? Where can it be improved, and so on, right? So how is this actually working? You can actually write this publication on any topic, well, data science specific, but could be anything. And it could be, as you can see here, it could be a proper research paper, a tutorial, it could be an academic project, it could be many other things, and it detects that, right? This is an agentic system behind the scenes. Now, so case study, I wanted to really talk about the case study. Now, the students, well, the users of the platform said, this is great. Can you help us write? Can you just actually write this for us, right? And you might say, well, isn't it, why are you helping people write? But English as a second language can be a challenge for a lot of people, and it's a fair point. And we are not doing their project. Their project still has to be done by them, and their code repository has to be connected. They have to write what they've done. We'll just do a polished work at it, right? So that's our case study, right? I want your brains to start thinking about this. Imagine the use case that someone, one of you, wants to, you've done a project, maybe you've done a team project, and of course you have some code repository and you have some technical write-up. It's not very polished, maybe a README kind of thing, 1-pager, 2-pager, and you want to give it to some AI assistant along with all the code, and you want it to write it. You want it to create a published, like a portfolio grade publication from it, not hallucinate, right? It should be all real information. And if that is the case, how would you build it? What kind of architecture should it have? And this is a real problem at Ready Tensor. We are actively working on it. It's actually been quite maybe a 6-month project so far, and we and due to other priorities too, we haven't finished it. But it's the biggest challenge is reliability, robustness, and that it doesn't hallucinate and make up stuff and all of that. And then also the creativity side. We don't want every publication to look the same, writing style wise or whatever. You should be able to have some user representation in the write-up. So it's kind of a typical creativity versus productivity thing. You want to automate things, it becomes very mundane, right? Very routine, same things over and over. Okay, so this is a real problem. As I said, agentic authoring assistant, this is what we are working on. I want to simplify it for you, okay? Because if you're thinking about this, it's a too complex problem even for us right now. I wouldn't be able to do justice. So let's simplify this. Let's say all we're asking is, given a basic description of the project, we would want this system to develop, to output a clear title, relevant tags. So we want to have some discoverability based on tags on the platform, on the project. A concise TLDR, like a very short snippet that goes at the top, what this project is about. Well, we are not going to do all this, but in the interest of time. But yeah, a nice visually attractive hero image that is representative of the work. By the way, in the last session, if you recall, we did generate images, so it's not out of question to be able to generate fairly relevant images today. And then one other thing, right? This is actually something quite handy. We use this ourselves is references. You do your work and you want some references around, similar work done in outside, and we would like to pull that information. Remember, I was talking about tools like web search and references, academic papers. This is one of those examples. So I want to just give you a couple, maybe a minute to think about it. Meanwhile, if there are any questions, we can answer those. But I want you to then think about what that pattern should look like. Okay. There is no right answer, by the way, here. So you just need to think about if given some context, some content like that, your project, and you just need a system to give you title, tags, references, a hero image, and I think I missed one more point, TLDR. What's the pattern? How would you put it together? So just think about it. Yeah, and then let's say if you have any questions in the meanwhile, I can answer those. Okay, we're halfway through. Good. Yeah, any questions? Or I'll just let you think maybe 30 more seconds. It's awkward to have silence, right? So there's like an urge to fill it. All right. Yeah, someone answered a network. Okay. Good. I'm just glad nobody said assembly line. But yeah. Okay. So maybe 10 more seconds. I'll just get going then. Okay. All right. So the system that we put together, and in today's example, what we're going to show is even lighter than this, because that graph that I want to show you, that implementation would have looked too complex. So it's a little bit even lighter than what I'm showing. But this is the pattern that we used. Okay. So there is a manager, and I'll explain why. Then you have these, in a way, like 4 agents, right? There's a title generator, there's a TLDR generator, a tags generator, and then a references generator. Their information goes to a reviewer, which is, remember that reflection pattern. Now we're kind of combining things here, right? As I said, you will never see one pattern exactly like this. You combine things. And so in a way, what you can see is this whole part is the generator, and this is the critic, and the critic says, no good, go back to better. So that is what is happening here. It can bring it together. Now, normally the issue here is not that you're you're getting bad results by itself. What can happen, which is why we needed a reviewer, we had a system without a reviewer at the beginning, is the title and the tags wouldn't quite align. Okay, and that can very easily happen where maybe the title is transformers for whatever image classification problem in XYZ. And if I just made that up, by the way. So if that is the case, you would expect transformers to be one of the tags and image classification to be one of the tags and so on, right? You kind of want everything to line up nicely, like they're together. And that was missing sometimes. It felt like different, music players playing different sheets and not singing together. So, or playing it together. So that's what the reviewer is supposed to do, is bring it together and then make a call on, okay, maybe this needs to be updated. Okay, and that is what we did here. References, by the way, references typically are not something about that. It might be like, okay, your references are not quality enough. So it's a little bit different angle there with references. Okay. All right, we're going to get into n8n now. I want to get into that. So let's see. Let me do some intro first around. Come on. So let's see. Intro, n8n. So when we implement agentic systems, there's a ton of choices in what tools to use. It's unbelievable. It's how many tools and libraries and packages you have these days. So agentic AI wise, there's maybe like four or five of them that you will hear. So n8n is the lowest complexity one, like easiest to use. It's basically drag and drop kind of thing. Okay, you have a GUI, like a web kind of platform, and then you're just dragging things and connecting them. So it becomes easier that way. Of course, you lose sometimes the flexibility that you can get with lower level code. So I had told my daughter, sorry, guy, if you give me 5 seconds, I need to answer. Okay. When you have teenage daughters, you will know. Okay, so so yeah, n8n is low code, okay, or no code. You can do quite powerful things with just drag and drop capabilities. So that's what we'll use. I mentioned. So one of the important things when you're building agentic systems is the whole uh, orchestration. Okay, you have to have like information flowing between agents and connecting them together and the loops as I showed you and so on. So all of that, if you're writing that code yourself, is quite a lot of code. Okay, you would spend a lot of maybe weeks, maybe sometimes months doing that. And so workflow automation is one of the most biggest reasons why you would use a package, a tool or a library for this. So that's n8n makes it quite easy. It has a visual editor, as I said. You can drag and drop things. You can trigger things using various queues, various starting kind of events. There's a lot of integrations they provide with different apps, APIs, and so on. And then any workflow that you have, you can share it with the community. So it's basically like and it's open source, I should mention. So it's quite developer friendly platform, although it's trying to be low code, no code. Okay. So, all right, I want to just talk about 4 things. Don't try to read the top chart. It's just how a typical workflow would look like. I just wanted to show an example. So there's 4 things that you should know in n8n. One is basically you're building graphs, so you have to have nodes, things where certain events or things are taken care of. Those are nodes. Nodes are connected by edges, which is basically information flowing, like the output of one going as an input to the other. I mentioned triggers are basically things that start off some workflow. And then the workflow is basically the collection of all these things together, like a blueprint of the entire process. Okay, so let's now jump into n8n. Okay, so by the way, if you go to n8n.io, one of the very useful things they have is this thing called templates. So if you go to product, you have templates. And what are templates? These are, as the name suggests, templates. It's basically like these skeleton workflows commonly used that other people might find useful, right? So I don't know. So I just did a session with a group of supply chain students last week, and they were quite interested in workflows related to logistics and supply chain. And then here you go, right? You have AI agents, different workflows. There's 5 of them for different reasons, right? Estimate driving time, geocoding for logistics, and so on. Let's see anything about education. There's one, I'm not sure what this is. Generate educational social media carousels with chat GPT 4.1, right? I don't know, healthcare, 3 results, and so on. So you can see, like, if you're in different industries, you might have some use cases here that some templates you might be able to just start from. That's quite handy. And in fact, we did that. We have used one of these workflows from the templates recently. So it's quite helpful from that perspective. Okay, real quick now, let's get into what you would do, right, when you're working with n8n. So where is my? I lost one of those things. Let me go back. It's not. Okay, so if you start with a template, then you can just import one. But if you start with a blank canvas, it's going to look something like this. We're not going to build one because it would take too much time. But just so you get oriented, right? You can start adding nodes into your workflow. So I'm just going to say, let's say you're looking for, let's say you're trying to automate something about your email. Whenever an email gets sent to you, maybe you want to look for certain types of emails and do certain things with them, right? So maybe it's a Gmail client and you want to have something related to it, right? So there's one here, and you can see there is a trigger on message received. So if I was using that, I'm just going to close back. You can see I've just added that node here. And what you would need to do, by the way, working with n8n is quite fun with this. The most troublesome and boring part is just setting up these configurations, right? Now I said, okay, Gmail, right? I need to connect my Gmail here. And then you have to read the docs of how you would do that. You need to have some kind of client ID and some secret and all that information so that Gmail will give permission to n8n to get your information, right? So all of that, usually you spend like 80% of your time just on the configuration of these nodes and then connecting them together. So let's look at some additional examples. I want to just make sure you understand, like, this is quite powerful. So let's say I mentioned Gmail, but really, if you look at Google, right, there's a ton of these things that you can use as nodes, as triggers. Let's say you want to do something about GitHub, your code, maybe some events related to your code repository. You can have integrations to that. Let's see, I don't know, weather, something about weather, you want to automate that and give you triggers. You can actually set up automation where you could send yourself a text message, an email, a push message. You could send a Slack message, a Discord message, those kinds of things, right? You could do a lot of these automations here. Maybe you're trying to get information from SQL, right? I mentioned you can extract information. So you have a couple of examples here, MySQL, Microsoft SQL, and so on. n8n, I would say, like, there's a 99% chance that everything that you need in your project, there's an n8n node for it. Okay, and in some cases you might need to write custom code, which, by the way, you can do that. You can drag and drop custom code, and then through code you can always do various things too, right? You can write Python code, you can write JavaScript, Java, and so on. So as I said, low code and no code. So there can be code elements in it too. Okay. All right. So I'm going to just go into the actual application that the example we were looking at, remember this one? So what does that look like? So let me just clarify. There's a couple of things missing in that example. So first is this TLDR. I mean, once you know there's a title tax generator is the same process, so it doesn't really matter. It's just one more agent we could have added there. And the only thing that only because of the complexity of how that node, the graph would have looked, we don't have a loop back. Okay, so we do have a manager, we have a title tags references generator. We do have a consolidator, and then we're going to dump that consolidated information into a file. Okay, so we want to basically show this kind of automation here. So there is no loop back. The revision part is not built, but very easily that can be built into the process. So again, remember the problem we are solving, right? Someone is writing a publication, but in addition to the assessment that I just showed you, imagine they just say I'm sure you're now used to AI agents like this agentic capabilities or LLM capabilities in various tools. Imagine if a user could just right click here and say suggest titles, right? And then it's getting that information now, getting the title. Or maybe there's a tags place and it just says give me tags, suggest some tags. Scrolls to the bottom and the user says give me references for this, can you suggest me that? So that's what we are really building here, but I'm simulating that through an n8n workflow. Okay, so this is that simple application. Looks quite complex, I know, but let me just show what's happening there. So what I'm going to do is, again, in order to simulate this here, my daughter keeps texting. Let me just quickly text back. Sorry. I'm really sorry. I thought my daughter knew this is going to be a call time, but there's always an emergency. There isn't one. Okay, so what I'm going to do is there is a Google Drive in which I'm going to put some documentation about a publication, and that is what we're going to review. I mean, pull, and then we're going to generate the information that I mentioned. Okay, so let me first just so I want to it's clear. I'm going to delete it. Let me do another one just so we have. It doesn't matter really. We could have put anyone. So I put a publication here, a project information. And what I'm going to do, I will run that trigger. I will explain how that thing works, but let me first clear. I was testing this before this call just to make sure it works, everything. So yeah, what's going to happen is this is a document which has information about a project. This n8n workflow is going to pull that from the Google Drive, and it's going to send it off to various agents, which I will show, and then come back with the information. And at the end of it, in this output folder, also on Google Drive, it's going to drop that information. It's not going to look pretty because remember, this information is actually getting sent to the UI that we have. And so we don't need to build a different UI, right? The information is going to be presented here to the user. So all we need to do is send that information back. So I'm just simulating that workflow through n8n. Okay, so let's see, what do we have? We have, let me zoom in a little bit. Google Drive trigger. Remember, it needs to pick it up from Google, that drive. There is something called, I mean, there's some processing it has to do. So I'll skip that detail, but pulling, like getting the document is not the same as reading it and parsing it. And so we have that second step here. There is a code node here to do certain elements with it. So, I have a JavaScript code, but you can have Python code if you wanted. Okay, remember the manager node I was showing here? We have a manager node. So let's see, what is the manager doing? This manager node has a set of instructions, which I will copy and show you in a different screen. Remember, I told you everything with LLMs are prompts, okay? There is no magic happening. There is just prompts. And so here, the manager, imagine if you go to ChatGPT, this is what you're prompting in there. Read the following input text, produce a clear internal brief to guide multiple agents working on different parts of the article. Your summary should do XYZ, right? There's like don'ts, don't do this, don't do that. The input should be, your input is, if the input is brief, shallow, make sure that you reflect that honestly. By the way, LLMs, as you know, are meant to be very pleasant. They'll never be harsh. And so you have to force them. They're saying, be honest, be transparent. It's okay to be rude in this case. So we have this information. And then what we are doing, this is the magic that is happening here is through n8n, the content, the document, we are just injecting that there. That's the only thing that is happening like through code that is more complex, but the rest is pure plain text prompt. And this is what we are saying. Hey, manager, do this. Here's the publication. Produce some instructions to send to the other agents, right? That's all. And we did that. That manager is going to then produce a brief, like a short description that is meant to be like a common brief, right? It's telling, hey, agents, we have a new job. You do this, you do that, right? That's the kind of manager instruction this is producing. And then it's then we are off, right? We basically send it off to different tasks here. We took a shortcut here. We basically produce one agent that does both the tags and the title. This is kind of, you have to test this out to make sure that it does both well. Otherwise, you should break it apart because sometimes these agents forget what they're supposed to do, and they either not produce title or they don't produce tags, and you just have to be careful. So that's why we usually break things apart. We did take notice that this was happening consistently. So one agent, we're giving the publication saying produce both, right? Comes out with that. Here is the harder part. Remember I said we have to do references. References have to be done by searching the internet. And so we have used this tool called, and I'm using the word tool here a little bit loosely, but just it's in functionality, that's what is happening. A tool called Tavily Search. If you get into Agentic AI, this is one of the names you will hear over and over, Tavily Search. They've kind of made it quite easy to search the net and give you information that you're looking for in a very nice form. So we are using that. You need to have a like API key with them, but it's free to use for the most part. So yeah, we pass on certain information to it. There is a query generator before that. Okay, so what's a query generator? So remember, in order to, if you're doing Google search on topics, you don't dump your entire project in Google. You look for keywords, right? You say, give me papers on this term or this topic, and you type a few words or one word or two words. We needed an agent for that. And that is what this query generator does. Okay, it's just another agent, generates the queries, passes it on to the tool, and the tool comes back with that. Okay, the results from those searches. We combine that with the information, and then we have a references generator, which is basically just modifying the information to present it in the form that we need, right? How you would want the references section at the bottom of a publication. Remember, you would have the author names and the paper, whatever information. So that kind of structure is what is being done here. We merge it with the tags and title. We create a JSON file from it. And normally you would have an API endpoint from here, but we are just dumping it into a Google Drive, right? So you can see how you just connect different nodes. The only thing, as I said, is reading the documentation of these nodes and making sure you know what the fields mean and what information you are supposed to put in them to make it sure it works. And that's it. That's an exercise of documentation hunting, really. But the rest of the part is easy. Okay, so let's try this out. I'm gonna zoom out a little bit. Okay, I think we can see all of it, I think. All right, so remember, I just put this document, this publication, and I'm gonna expect to have some output here at the end of it. Okay, let's run this and watch the magic happen. You can see it's going, various nodes running. Okay, so we're gonna run out of time. So I mean, we're close to the end of the demo, but I will come back with to the question section. All right. This thing is happening in sequence, but really there's a way to make this run in parallel. And when it runs in parallel, you obviously save time, right? So right now it didn't do that way, and that's just a configuration thing. Okay, let's see. Here you go. We have the output in this output folder. As I said, it's not going to look glossy and glamorous, but here it is. It produced a title, an empirical evaluation of class imbalance strategies in binary classification. I promise you, this is a very good quality title to that project. And then it produced a bunch of tags, which by the looks of it are all relevant. These are the things I would put in there, maybe not the last one. I don't know, that's not a useful tag, but most of them are quite useful. And then you can see certain references that it attached here. Now I will spare this because we will get into too much. But this is, we had limited the references to be just 3, by the way, but you could come up with 10, 20 if you wanted. Of course, the quality starts degrading, so you do need the reviewer node in that case. Okay, that's the end of the demo. Let's just wrap up with some key points I want to make sure you all get. Okay, because I'm going to send you the deck. There's a few slides I won't cover today, but I want to give you the main points here. Okay, all right. I don't want you to get too attached to any given tool. Agentic AI is extremely powerful. We are quite excited about it. It's just one of the tools. So there are many other things, many other technologies, many other tools that you can use to solve problems. I may said this before. I'll say this in this session and also the next session. Be a problem solver. Don't be a tool expert. Don't be an n8n tool expert. Okay, you just want to solve problems, and you pick the right tool for that. So Agentic AI is just one of the many technologies. There's others. RPA, robotic process automation, is just pure automation things. The way they've been done for the last 3 decades, four decades or so, still powerful. Machine learning. There's statistics, simulation modeling, operations research, optimization theory, different kinds of technologies, techniques, tools. You should all be aware of them, be a problem solver. The main point I will give you at this point, main takeaway for you, in any industry that you are, doesn't matter what industry you're in, software, you're in healthcare, hospitality, financial services, what have you, be an expert in that space. That is what will get you jobs. That is what will get you career advancement. So be a problem solver, be a deep thinker in your field. Tools are just ways to get projects done. All right. So I will stop here. Sorry, I meant to give you at least 5 more minutes for Q&A, but I'm here. I can answer questions. So let's open it up.
Dr. Desai, I see a few questions in the chat from Maria. So I'll start with probably her most recent one, asking, is that embedding? And can the 8n8 run locally, or is there some similar tools that can run locally?
Okay, that embedding. No, there in this particular example, we are not using embeddings. So I basically gave that's a really good question, actually. Now I think what you're really asking about. This publication, it can fit entirely in the prompt context. So we did not need to do RAG. If we had like a lot of documents, right, you would need to do extraction of certain elements. Here we are saying, here's the entire publication, right? Now give me a title that is appropriate for it. Give me tags, give me references for it. So it all fit in the context. We didn't need to do RAG. We didn't need to do any kind of embedding work here. It's pure LLM workflows, input and output, just like you would put in a chat prompt in ChatGPT. Okay. n8n can run locally. Yes, n8n can run locally. n8n can run in the cloud as well. Both possibilities are possibilities are there. The cloud one, there's some limits. You will need to pay at some point. So I think they only have like a 14-day free trial if you want to do the cloud version. Might be 1 month, but it's a limit. Okay. All right. Do you know what happens with errors here? Errors. Yeah, this is the topic of next workshop. Evaluations, hallucinations, safety, security, reliability of the systems. How do you make sure that the responses are correct, factual, grounded? That's the responsibility of any agentic AI system developer, that you make sure that it does no harm, it does not mislead, and it is acting in the right way. So we'll talk about that in the next workshop. But a very important topic, and it's an important thing to discuss in detail. Okay. Any other questions, comments? Okay, I hope this was helpful for you. We'll do one more workshop, but thank you, Diana. I'll let you close.
Thank you so much for your expertise and sharing this demo with us tonight, Dr. Desai. And thank you to all the students and the alumni who joined us tonight, and hopefully this is valuable. Thank you for your patience, and I will be sending out the recording and then the slide deck shortly. And we hope you'll join us for the next and final series. It's on Thursday, November 20th, 4:30 to 5:30 p.m. Pacific time. Thank you all, and have a great evening.
All right, thank you.